Hi guys, Buildzoid here, and today we're going to be taking a look at an RX 6600 XT PCB, the Sapphire Pulse PCB more specifically. So the PCB pictures are from Tech Power Up's review of this card, so if you want more details about it, you should check out their review. There will be a link to it down in the description. And thank you to Tech Power Up for providing, very high quality PCB pictures in their reviews, because it makes it possible for me to make videos like this. So yeah, let's get into it. So I chose this 6600 XT specifically because of the 6600 XT PCBs that I've seen so far. I rather like this one, whereas the other ones are, or more like, I rather like this one, and I also find it more interesting than a lot of the others, and overall 6600 XTs are kind of as far as a GPU release goes. But at the same time, that you might be interested, like you might not have any other choice but to buy one of these. And in that case, the Pulse is a interesting option. Let's put it that way. It's not like they've done anything wrong with it. In fact, I'd say they've done a lot right, I guess. I don't know. I'm not I'm not used to saying nice things about cards. Let's get into it. So, starting off with the main power delivery, which is this right here. So these two phases at the bottom, those are the SoC power, which probably powers the Infinity Cache primarily, and maybe some memory controller type stuff. Then above that, we've got a bunch of V-core power. So that's sort of the main power rail over here. And both of these rails are controlled by this chip over here, which is and we are not going to fit on this layer if I keep writing in that direction. So that right there is a IR35217, which is a rather high-end controller. Then again, these cards are $380, so I don't know why they'd be trying to save money by using cheaper ones. Running on this card in a rather interesting configuration, this is actually running a 6+1. And the reason this is interesting is most cards run a 6+2 configuration. But Sapphire has opted to set this PCB up for a 7-phase V-core, and that controller only goes up to 8 phases total. So the way they're actually getting the 2-phase SoC down here, because the SoC is a 2-phase, is, or at least I suspect this is what they're doing, is this chip right here should be an IR 3599 doubler and or quadrupler. Which here it's being used as a doubler, as we do have 2 phases of SoC power, and then we have the positioning for 7 phases of V-core, though they've only populated 6 of them because, well, it's a 6600. Like, this is their budget model. I assume they might do it, maybe they'll do like a 6600 XT Nitro where they'll include this extra phase. Not that that will make much of a difference, but they certainly have the option to do that if they feel so inclined. Anyway, so yeah, 6+1. The 35217 is the VRM controller originally introduced with the Vega cards. So a very high-end international rectifier, digital VRM controller, goes up to ridiculous, 2 megahertz switching frequency, does everything you would want, supported by the Elmore EVC2. And speaking of Elmore EVC2 support, so, the 35217 is supported by it, and if you wanted to connect an EVC2 to this card, it looks like the I2C header is right here, and that might also give you control over the NCP81022, which is used for the memory rails, which is this chip over here. We'll cover, well, the memory and memory controller power delivery, so that's the 81022, and anyway. So yeah, the V-core controller, honestly, that's a nice V-core controller. Also, it's standard for 6600 XTs to use this, probably just to do with the power management requirements that AMD has for their 6000 series GPUs. That is actually one of the big differences between really old controllers and the new ones, is the really old ones wouldn't necessarily be able to keep up with the very rapid, the power state, rapid voltage level changes that a lot of modern GPUs have in order to really maximize their power budget. So anyway, yeah, that's our controller. And it's, 6+1 with the 3599 for the 2-phase SoC VRM. So we do have some doubling for the SoC VRM. I don't really have a problem with this. Like, technically speaking, doublers do add a very small amount of delay to the PWM signals, which can lead to ever so slightly worse transient response. However, that can be easily mitigated by just a better capacitor configuration or like tweaking other design parameters of the VRM to just compensate for that. So yeah, I don't really see any problem with Sapphire doubling the SoC rail, especially since this isn't even a like clock region on the chip that you get control over. At least not from AMD. Technically, you can now overclock the SoC on these cards with soft power play table mods, but yeah, like natively, this overclocking the SoC isn't supported, and I don't see any reason that this should cause any, like this being doubled should cause any issues. For the vCore VRM, that's just a straight 6-phase, so nothing weird going on there. And in terms of the power stages used, we're looking at a bunch of NCP 302151s, and these are 55 amp DRMOS components, so they're a bit dumb. As in, they have a thermal warning system, they don't have any temperature monitoring, they don't have any current monitoring, and they don't have any safety functionality built into them. So yeah, that's kind of what's going on with those, and those 5s are horrendous. Yeah, and we have the same DRMOS components used for the SoC rail. So in terms of output power, the vCore rail can handle 1 volt output voltage running at a 500 kilohertz switching frequency. That statement doesn't make any sense now that I think about it. Either way, outputting 1 volt with a switching frequency of 500 kilohertz, this VRM can output 90 amps while producing about 9 watts of heat, which is great efficiency. 120 amps of current while producing about 11 watts of heat. So this is actually where it hits the peak of its efficiency curve, at least for 1 volt output. 150 amps output, it'll produce about 15 watts of heat. So now the efficiency is starting to drop off again. 180 amps output, it'll produce about 20 watts of heat, and 240 amps output, which is actually the, like, if you're wondering why we're just skipping from 180 straight to 240, it's because 40 amps is at the ending of the rating curve on the DRMOS components here. So they are nominally capable of 55 amps output current, but the documentation only goes up to 40 for these, because if you actually push 55 amps through them, they're going to be so inefficient that, and so, like, they're going to produce so much heat, it's going to be extremely difficult to cool them. It is technically possible, but not practical. So anyway, 240 amps output, these will produce about 32 watts of heat, which really doesn't sound that much until you consider the fact that that is over 5 watts of heat per component. So they're going to be running pretty hot at that point, even though this really, like, in terms of efficiency, that's really not that bad. So yeah, that's the current handling capacity of this VRM here. It's in line with what you'd see on basically any other 6600 XT. 6600 XTs have a very low stock power consumption, so I can't imagine that this would really, well, within the stock overclocking limits, this isn't going to limit you, and I don't really see a reason that this would cause any issues if you're doing, you know, some amount of overvoltage, which again, you'll probably need an EVC2 to do that. Actually, not necessarily. Like, the main thing is, if you can get access to the 35217 somehow from Windows instead of through a, like, dongle, then you could just, you know, set a voltage offset through that. But I'm not sure that there's any way to do that currently. And AMD certainly doesn't allow you to do that, so that's a bit unfortunate. But, yeah, like, the VRM here is certainly capable of providing a lot of power, certainly a lot more power than these cards pull at stock, so overclocking headroom in terms of at least the VRM capacity should be quite good. The SoC rail, being just 2 phases of the same power stages, is capable of outputting 30 amps while producing about 3 watts of heat, and 40 amps while producing about 4 watts of heat. If you're wondering what's going on with the figures here, or more like this and this, that's because of the rounding. So I think this ends up being like 11.4 watts, and so it gets rounded down, whereas this ends up being like 3.8 watts, so that gets rounded up. Yeah, and also it's worth noting that technically all of these heat outputs are just for the power stages themselves, not for the whole voltage regulator. So, the efficiency figures are a bit higher than they should be, but close enough. Like close enough. For comparison purposes, this works okay under most circumstances. So anyway, that's sort of the main core power rails, and there's really nothing to complain about there. It's not like you can get a better 6600 XT, and it looks, well, maybe Sapphire will make a version of this PCB where they do actually fill out all 7 phases, and you'll get slightly more current handling capacity out of that. But it won't be a very large increase in current handling capacity, because it really is just like one more phase on a 6-phase design, so it's not a huge difference. Anyway. For memory and the memory controller, we've got this rail and this rail. I'm not sure which one's which, but if I had to guess, this one's memory and this one is the memory controller, also known as VDDCI. Both of these actually use different power stages. So these are on NCP, and I should not have put that directly over a screw hole, NCP 3020 45s. These are 45 amp DR MOS components, so slightly less powerful, but the thing is, this card has no memory on it. Like, this is all of the VRAM. Honestly, like, it's ridiculous to look at these. Like, this has 4 memory chips on it. This is, like, if you told me that we're gonna have a $400, roughly $400 GPU with 4 memory chips, I wouldn't believe you, because 128-bit memory controllers are like to me that sounds like a $100, maybe $150, $200 card max. But AMD right now, of course, GPU prices are insane, so that's a big part of it. Under more reasonable conditions, this would probably be much, much cheaper, because this doesn't have, like, the memory controller on this is tiny. And the whole memory system on this is tiny. So that's also why we don't have to be too worried about the memory power delivery. Like 45 amp DR MOS components are more than enough to power just 4 chips of GDDR6. Like that's kind of like, it's so weird to see that on a card in this price category. It's just like, it's literally just 4 memory chips. Because each of the memory chips has a 32-bit wide memory interface, so for a 128-bit memory controller, you only need 4 of them. So that's, like, it's not weird, like, it makes sense for the configuration of the card, but yeah, like, this is the kind of memory controller that you'd expect to see in the low end, not what I guess AMD is trying to call the mid-range, though. I don't know. I feel like this is a low-end card that got pushed into the mid-range by the fact that, like, all of the actual mid-range cards are selling for insane prices. So, yeah, that's my thoughts on it. I don't really see this as a real mid-range, like, this is not a real mid-range card. It's just kind of the only available mid-range card, I guess, is one way to look at it, which is very unfortunate. The good news is, yeah, the power delivery for the memory ends up being just basically nothing, and you don't have to worry about it, because there's like, the memory controller's tiny, there's very few memory chips, it's not going to pull any power. And the voltage controller for the memory is the NCP 81022, and this is a controller that AMD's been using for ages and ages and ages. It originally was used for vCore on the HD7 790. Here it's running as a 1+1, so, 1 phase for VDDCI, 1 phase for memory. It goes up to, I believe, 1.2 megahertz switching frequency. Very easy to mod if you wanted to do that, like hard mod, because it just has feedback pins straight up, so very, very easy to modify. You can also very easily disable the current limit on it. The only issue is, I'm not sure that there's much point in doing that on a card like this, because the memory is probably not, like, if this is anything like a 6900 XT, the memory probably doesn't scale with voltage. So there's not really much point trying to mod the memory the memory power delivery rails. So yeah, either way, in terms of actually providing power to the memory, this is more than enough. Other minor voltage regulators that we have around on the card, well, there's supposed to be a 1.8 volt rail somewhere. If I had to guess, it's this. And there's also a 0.75 volt rail, which is probably that. So I'm going to put a 1.8 volts question mark and 0.75 volts question mark because, yeah, I'm not sure about those, but I've probably, like, my guess is probably right. Wait, what's this thing? Okay, I'm very much less sure now. I have no idea what this is. I am now very confused. What is that for? Maybe these are swapped. Okay, so I'm taking... Wait, oh wait, there's got to be a 5 volt rail. Okay, wait, this is probably 5 volts. Because the thing is, so GPUs generate their own 5 volt rail because they only get 12 volts and 3.3 volts. Power stages don't run on 3.3 volts and they don't run on 12 volts. They run on 5 volts. And so if you want to use power stages, yeah, you're going to have a 5 volt regulator, which is probably this. And I'm guessing it's that because it's the smallest buck converter I can see on this card. And the reason why I'm using the fact that it's the smallest buck converter is because the power stages really don't pull much power. In fact, a lot of cards will just opt to use linear regulators to convert 12 volts down to 5 volts, which is horribly inefficient. But the thing is, you really don't need a lot of power to power the power stages. So a linear regulator will do a perfectly good job of converting 12 volts to 5 volts if all you need to do is power, what, like 10 power stages? Yeah, we've got 10 power stages here, so you don't really need, like, this is honestly kind of overkill for the 5 volt rail there. But nothing wrong with that. And then this is probably 0.75 volts. There. And I'll leave the question marks in place because I'm still not sure about those. So that's sort of the main power delivery stuff on this card. Is there anything I'm forgetting about? Not really. Sapphire certainly left a lot of options for themselves on this PCB. It looks like we've got functionality for dual BIOS with the missing second BIOS. Like, this looks like a missing second BIOS chip, especially if we check the back of the card. I bet on the opposite side, yeah, that's our BIOS chip. So they have the option to make a dual BIOS version of this thing. What else do we have? That's kind of it, I think. Oh, it looks like they had an RGB header over there. But, yeah, so that's kind of it in terms of, like, unused features on here. Right, like, you have the missing seventh phase and then maybe an LED switch as well, along with the BIOS switch. Anyway, the other feature that I really want to point out on this card is the fuses, because Sapphire is one of the few GPU manufacturers these days that actually has board protection fuses. Now, the reason I call them board protection fuses is because they're not there to prevent component failure. They're there to prevent further damage after component failure. One of the most common ways for a GPU to up and die is for the power stages to just fail short circuit. And the problem with power stages failing short circuit is that when they fail short circuit, they get extremely hot, extremely fast. And the end result of that is you can end up with power stages welding themselves to the PCB, vaporizing themselves, and a good chunk of the PCB, like leaving a burnt crater in the PCB. Like, the amount of damage that a failed power stage or MOSFET can cause to a PCB is really quite impressive. And one of the best ways to minimize that is to limit how much energy the power stage can pull before the power gets cut, right? And so that's the idea behind having these fuses, is that in the event that, you know, a power stage fails, this will basically disconnect the power, like the GPU from the power supply. So all of the, like, the only energy that the power stage is going to have available is what's already stored in these capacitors, which can still be kind of a lot, but it's going to be less than if you also had the entire power supply hanging off of it, as well as all of the other capacitance in the system. Because technically, like, your motherboard has a bunch of input filtering capacitors that store 12 volts power. Your power supply has a bunch of filtering capacitors on its output that store 12 volts. So if you have a short circuit through a MOSFET from 12 volts to ground, you want to really cut the connection, like, you want to disconnect the power supply from that MOSFET as quickly as possible. Because it will just, like, until the voltage drops to 0, it will just continuously pull power. And in the process just generate more and more heat, causing more and more heat-based damage to the PCB around it. So yeah, the thing is, so these fuses don't prevent the card from failing, but they do make the job of repairing the card much, much easier for whoever's going to be repairing it after it has failed. So I'm a big fan of those. And oh, I guess I could have mentioned who the like main capacitor actually only capacitor. Yeah, so all of the polymer capacitors on this card, so both the output and input filtering capacitors, are made by APAC, which is a Taiwanese capacitor manufacturer, and they're really common on like low to mid-range motherboards, GPUs. They're a very, very popular capacitor brand. These are solid polymer capacitors, so they don't really do spectacular type failures unless you seriously misuse them, like installing them backwards. That'll get them to pop, but under normal circumstances, these really shouldn't fail. Basically, regardless of who makes them, because there's not like, oh well, you can also overheat them a lot, but like you need to, again, that would be like consequences of other, like that would be a design flaw kind of issue. That wouldn't be the fault of the capacitor. So yeah, and Sapphire also opted to use 5,000 hour rated capacitors, so that's going to be 5,000 hours at 105 degrees Celsius before they lose 20% of their, well, rated performance. So they still work after those 5,000 hours at 105 degrees, they just work less well. Yeah, that's kind of it. They did kind of cut down on the, bypass capacitors directly behind the GPU core, as we're missing some of these large multi-layer ceramics. But that shouldn't really affect anything too much. Otherwise, they would have included them if they did. That's kind of the idea behind that. So, yeah, that's the Sapphire 6600 XT Pulse PCB. We've got a solid-looking V-Core VRM, the usual SoC VRM, memory and memory controller VRM that look adequate for what they need to power, which is very little, right? And then we've also got board protection fuses, which are just a cool feature to have. It's very easy to potentially connect to the EVC. To the I2C connection of the 35217, as well as the NCP 81022. The NCP 81022 is just a bit more limited in terms of what kind of controls you get over the I2C connection. And yeah, so all around, just a solid solid little PCB for a 6600 XT. And it is kind of little. Like, it's not particularly huge. There are some 6600 XTs that have a PCB extension on the end of them where there's not much, but just blank PCB. So yeah, that's it for the video. Thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comments section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below. There's also the AHOC Teespring store where you can pick up shirts, stickers, posters, the usual YouTuber merch. It would be much appreciated if you check out the Patreon or the Teespring, as they both help out immensely with running the channel. And that's it for the video, so thank you for watching, and goodbye.